Hi guys, welcome back to the channel. So let's go to the post. Um, 1 minute, guys. So uh, last time when I remember, we have done k different pairs in an array. So seems like the sliding window problems were completed, and we're moving to this rotation thing. We don't know what it is, so let's see what it is. Okay, it's a medium level problem, and it is LeetCode 1861. And let's also see the concepts that involve two pointers matrix. Wow. Okay. And rotating the box. The problem name is rotating the box. So the problem statement goes like this: you're given an m by n matrix of characters. Okay, the matrix name is box grid and it's of size m by n. So it's not a square matrix, and it contains characters representing a side view of a box. Okay, and it represents a side view of a box. Each cell of the box is one of the following. It can be hash, which represents stone, and star, which is a stationary obstacle, and dot is empty box. So the box rotated 190 degrees clockwise, okay, causing some of the stones to fall due to gravity. Each stone falls down until it lands on an obstacle, which is star. Another stone or bottom of the box. Gravity does not affect the obstacle. So each stone falls down until it lands on an obstacle. Another stone or the bottom of the box. Okay, the stone falls down until it lands on an obstacle or another stone or the bottom of the box. So the stones will not be what do we call it? Uh, the stones won't be disappeared. They will be move like they will be changed from their positions. That's it due to gravity. And it's a simulation kind of problem, guys, and gravity does not affect the obstacles positions. Okay, the static obstacles will not be affected by the uh, what do we call it, gravity. So even if we turn it 90 degrees, thus we do not need to change stars, we do not need to touch them. We have to change the hashes, and if hashes moves, it might occupy some of the dots, and a hash might become a dot since it will become empty. And the inertia from the box rotation does not affect the stone's horizontal position. Okay, so it will just fall vertically. It is guaranteed that each stone in box grids rests on an obstacle or another stone or the bottom of the box. So we have to give the stone's position. I mean, we have to give a matrix, written a matrix of size. It's m by n, right? So if we rotate it 90 degrees, it will be n by m, and we have to change the position of the rock. So in this diagram, the matrix is of size three columns and two row. I mean one row. So 1 by 3, it will become 3 by 1 matrix. So if we rotate this 90 degrees, since it is in the bottom, I mean at the bottom position, it does not move, but this will fall. to this position. So this is it, and let's and in this case, if you rotate this will only fall, and in this case it will fall down. This will fall down, this will also fall down, this will also fall down, and these four will be moved and remaining will be the same. See, and m and n will be between 1 and 500. Okay, so let's think about the intuition first. So how are we gonna do it? Hmm. So we can do one thing. If we have initially we have to rotate the matrix vertically. After rotating, if we have dots below the hashtag, we are gonna swap them. So initially let's do one thing. Let's rotate the matrix. So how are we gonna do that? For row box grid. First row. No. We have to first take column. And we forgot the questions. It will be between 1 and 500, right? So let's do one thing. Number of and columns, right? So for range of columns, for three, uh, column. First column, second row, sorry. So let's see if our loop going right. So I think what we did initially was the correct one. Right. So now we have rotated it. To box. This is follow insert. So currently the time complexity order of m into n. I think it's not going well. Now let's finish it. So it's something wrong here. Shit. Oh, sorry, guys. I think ours will work fine, but I am printing temp here, so that might cause a problem. Well, it is working as we are expected. So let's go to the next step. No, let's delete. This will clear the memory. Now we have to check the below columns, right? How do we check it? Okay. So we are going through each column. First column, one row, first column. Let's see, yeah, this example. Actually, let's see this one. It's better. So first row, first column, second row, first column, third row, first column. So it's star. So let's break it here. Let's go to second column, first row, second column, second row, second column, third row, second column, fourth row is static object. So now let's start from here again. Third row, first column, first row, third column, second row, third column, third row, third column, fourth row, third column is empty. So we're gonna move this to this, and this to this to this, and here we'll keep the empty space. I think it's better if we are checking from the bottom. So first row, okay, we have to maintain another static point where the problem is really simple, but the complexity is the toughest thing here. I think you can keep a for loop here. It will make our life a bit simpler. So we are going to each column, first column, second column, third column, okay. And we are starting from bottom of the column. Okay. So from here to here, we are updating the static position support. So initially the support will be this, the last one, and when we move to here, it will become the support. Now we will move to here. The support is still this one, and later we will move to here, and the support will become the star now. And when we move to here, this will become the support again. And later this will become the support. So row minus support. Sorry. We have to also save the last empty grid. Go from here to here. If we get hash here, then we should not like we should not upgrade the support. We have to if hash hash dot okay. Now this is being tricky. So when we start from the here, we will find support here. And if you find this hash, if hash minus support, so this is n, support minus row is 1. This support and this row is here. support is dot. Then we have to swap. We have to make changes. We have to still make changes, but wait a minute. Sorry. Let's see now. Oh, So first row, 0th row, 0th column. Sorry, R will be starting. Here the matrix is 3 by 1. I mean 1 by 3. So one row, 3 columns. Here 3 rows, 1 column, right? So here 0th row, 0th column. First row, 0th column. So here the row is 0. The column increased somehow. Sorry. So it will be m columns and then rows. Like so. Need this. Oh, never mind. Fifth row. 3, 4, 5, 6. Okay. Fifth row, 0th column. Fourth row, 0th column. And it's according line number 21. Huh? So this. Um, so it didn't change anything. That hash star. Since it's completely ruined. One, two, three. Okay. Since the slide has no empty points, let's say this one, and one empty point here and a support here. So until support reaches, we'll swap star, dot and hash. And hash dot. Dot hash. Right. So I just got an idea. Equals to 0. One. Stop. Let's keep a pointer here and move it 1, 2, 3. So here we got a static point. So the next dot, we'll move to next dot. What do we keep it here? Okay. If start is not a hash, then we'll change start to the next point. One minute, guys. Okay. If start is not a hash, then we'll move it until we get a hash. If we find a empty row, so we are moving through. If we find a dot, we found the, we know that the start is a hash, so we kept start here itself. And if we find a dot, we'll swap. Now the start will be here. So now we find a star. If we find a star, So start will be shifted to star, and then the next iteration let's see now what happens. It seems it's not changing even a bit. Why? One row is less than. There is no change at all. Let's see if it is getting inside or not. So start is 0. If it is star, yeah, 0th row. Now we have so 0th is 0th column, first column and second column, right? Okay. So if the first column let's debug it and see what's happening. Okay, so it's not entering the condition if does not equals to star. Maybe this is why it's causing a problem. Okay, now the start is 1. Now we're printing start. We should print start here. Okay, this is fine. Oh, star dot dot. So this is somewhat something is fishy. Hash dot hash. How should it be hash dot? It should be dot hash, right? So hash dot star dot hash. So this is the row. So hash dot hash star dot. This is fine. Now this hash has to fall here. But instead the expected answer is hash dot. How is it? Let's see if anyone has a complaint about it. Uh, okay, wait a minute. Are we rotating it correct? If we rotating it 90 degrees right or clockwise, then it is hash if we rotated that hash hash dot or dot hash 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 star dot, so hash. Okay, I got it, guys. So we are not rotating it clockwise. We are actually what we are doing is we are mirroring the uh, this one, so it should not be mirrored. It should be uh, what do we call it? Rotated. So that's what we are doing wrong here. So how do we rotate it? Let's see. Ding. Hash 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 dot star. Let's see this case. We will understand it clearly. Hash. Okay, we just have to reverse them. Hash dot hash. Everything is fine, guys. We just have to reverse them actually. So what are we gonna do? Instead of going from first row to last row, we shall come from last row to first row. dot zero. We can do reverse for each block, but reversing would take order of m or n time. So what can we do instead? So first row, first column. Okay, I think it's not rows. We have question columns. Oh, ah, so how are we going to rotate it? Yeah, I figured. So actually, the last should be first. So let's think through it. So we have reversed columns, right? So we will get from last column, but last column doesn't gonna change anything. Sorry, here, right? We have to check it here. So here we have to take the last column, element in the last column, and put it in the it will be helpful. So instead of going hash 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 dot dot, sorry, let's take something distinct. Hash 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 again, star hash hash. So if we take star hash hash, we have to keep hash hash tab. So we have to go from the last row to the first row. Okay, so last row to the first row, and or instead we can do this. Dot hash hash dot hash 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 star dot hash dot. So it's working good. Hash dot hash hash star dot. Guys, if I am if I have to do this problem, maybe 2 months back I couldn't have done it, but seems like we are progressing. Let's try running it, and if it goes well, let's submit it and discuss the intuition after this. Oh shit. But we are there 34 test cases were passed, so yeah. So what are we doing here? First row first. So okay, star. So the start will be here, star. Since we have encountered star, start will be here now. And sorry. So start will be here. Since I encountered hash, now star. So start will be here now. And in the next iteration, start's gonna move to this position. And if okay, let's see this. Great. Let's try submitting again. And if it works, let me explain the intuition. Great, great, great. But seems like there is even more optimal approach. So in our case, we are using order of n square time complexity here and order of n square time complexity here, and seems like in memory constants wise we are working good. Now let's ask, I mean, let's discuss the intuition and see other solution. So our intuition is simple, guys. What are we doing? So initially we are checking for an edge guess if uh, the size of the box grid is 1 by 1. We are returning it as it is. If the if the so we have initialized rotated box here, and so we're going through each column and inserting a list of zeros and going through each row and updating uh, the value in row column into the column row. So instead of directly swapping them, what we're doing, if we swap them, then the box will become uh, not rotated one. It will become mirrored box. So we don't need a mirrored box, we need a rotated box. So instead of adding in the uh, box grid of row column, taking elements from box grid of row column, we are taking it from this m minus 1 can be added here also. So instead of taking it from the uh, direct row, we are taking it from uh, the opposite counterpart. So if row is 1, then we are taking the ending row, and if row is 2 here, we are taking the second last, and if it is 3, then third last, if it is 4, then fourth last. Like this we are going forward, and now we have, like, you got a rotated box. And since we got rotated box, we don't need this box grid anymore, so we are removing it. Mm. So now what we are doing is we are going through each column, and for each column, so consider this rotated. I can't rotate it for you guys, but if we rotate it 90 degrees, then we'll have this as a first topmost grid, this is the second, and this is the third, right? So now this is, so the starting should always contain a stone. So we are starting the start at 0, And after entering into the while loop, if the if the start is less than n and it is not a stone, then we are incrementing start until we get a stone. Let's keep a gap here for a clear understanding. And after that, we are checking if the row, actually we can, okay, okay, no problem. So, and we are checking the row if row has a star or not. If row has a star, okay, let's do one thing. Instead of going through this hassle, we can do one thing. Well, it seems this will even more optimize in terms of time complexity because the row should always be greater than the start. So with the start, we are increasing the row also. Uh, let's see. No, 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 no. Now it should be fine. Let's submit it and check. Oh, seems like nothing's happening. Let's ask ChatGPT if we can. Let's do one thing instead. So it's ranging from 30 to 380 milliseconds, right? So probably we didn't have a optimal solution. It can be even more optimized, and the space complexity lies between 47 and 60. So probably this also can be optimized. Let's ask ChatGPT. So I didn't explain the intuition right. So let's ignore the edge case. So actually we are rotating the uh, complete array here. I mean 2D array. So why, if you have any doubt, it should be this logic only, because remaining all are very simple. So this logic, what it is doing is, so if you change row column value to column row value, just remember that it will mirror the object instead of rotating it. So to rotate it, uh, you have to take the counterpart, opposite counterpart of the row. Like if the row is zeroth row, then it should be the m minus 1, so last element. And if row is 1, then m minus 2, like that. And we are removing the box grid. We are going through each column, and we have started a pointer here, and incrementing the row as we go. And if start is not a stone, we are incrementing until we get a stone. And if start start outgrows the row, then we are increasing row also. And after completing this, if row is less than n, if row is less than n, and if the rotated box, if that row contains star, then we are moving star to row point. And now, or if we have dot instead, we are swapping uh, the starting point and the stone. I mean the starting point where the stone exists and the empty place. And we are increasing starting point to +1 and increasing row to +1 as well, because we have swapped it or we have checked it. So again, if in the next step, if we didn't find the, if we didn't have start as a stone, it goes through the same thing. So I hope you guys understand, and let's ask ChatGPT if it can be even more optimized. But the order of m into n is inevitable, right? So how can it be optimized? If it can be optimized, then we'll be learning something new today, guys. And if you have any doubt, why is it a slide two-pointer problem? Because we are sliding a pointer vertically. I mean, sliding a window vertically. If the window has any empty spaces, then we are shifting stones to that spot. Guys, I understood why this is giving very late responses because this chart is very huge. I have to create a new chart and delete this one. I see what you are solving it for. Okay, but your approach does two expensive passes. First rotate, then gravity simulation column by column on the rotated box. That's fine for correctness but not optimal. You can merge these steps and avoid redundant memory operations. Okay, extra space for rotation. Oh, you store rotated box fully in memory, which is order of m to an extra space. You can instead simulate gravity before or during rotation. Our complicated two-pointer loop. You maintain start and row to find stones and move them, but this can be cleaner if you use a fall position pointer from bottom to top. Two-step logic causes cache inefficiency. Rotating first and then simulating gravity means we touch every cell twice in different orientations. More optimal idea. Instead of rotate and then apply gravity, we have to apply gravity per row. Gravity in the original box is simpler to simulate. Gravity in the original box is simpler to simulate, and rotation afterwards won't change the result. Okay, so what he is saying is instead of applying gravity in the downwards direction, he is asking to apply it in the right side direction. Applying gravity in the right side direction. Okay, for each row in box grid, use a two-pointer approach from right to left. Keep a right position. Whenever you see a star, reset right position to the cell before the obstacle. Whenever you see a hash, move to the right position and decrement right position. After gravity is applied to all rows, do one pass rotation into the result. Let's see what he's doing. So he's going through each row, and the right position is the ending point. Okay. See guys, it is also order of n square only, but let's see. So if the row and column is a star, then the right position is C minus 1. Okay. If box position, if the item is a stone, okay, we are keeping it a empty space and changing the right position to hash. So if box however is star, it is going to C minus 1. I don't see anything different guys because uh, it is doing the same thing but in a reverse order. Order of n square and order of n square. No rotated box. Yeah, it's a box. It's all similar. Let's see if it is beyond us, then let's revisit it later. But it's worth seeing, right? So let's see the answer now. Oscar software. So let's nice. Guys, it's the same exact code as the previous one, and people are saying we are gonna lose our jobs to AI. See the context awareness, guys. Well, it will happen sooner or later, but it only takes out the what do we call it, mundane work, and leaves us the uh, quality work to be done by humans. And if the quality work is also automated by the AI, and it is very reliable, then humans can focus on research instead of doing all mundane works like uh, lab labor work, or even blue collared and white collared work. If it can be organized, and if it can be done, it seems like our approach is fine, but the logic is not as like not as good looking as theirs. So this part is fine. This is the only part. So for that, what are they doing is right pointer to left of obstacles. So if we find a star, then we are changing the right pointer to the same and front position. And if we find a stone, then we are keeping a empty position in the stone, and okay, right stone in the right position. Okay, I understood, guys. Oh, if it's a star, then and if it is a stone, we are changing the column to dot, and let's see if it works. Wait, I think we have to move row in the reverse order. Right, here they are doing the C, but both are same. So Let's see how well this works. See guys, this didn't take anywhere near to the 100%. Just one thing, why not see the code that's done by human? Wow, simply elegant guys. It can like it's done in two loops itself. So it is also order of m into n, but it is smaller and it, so he is taking it as ith row and jth column. So it's taking the last. Okay. Okay guys, he is doing the same thing but doing in a different way. Uh, this is as we study like seen the comment. If we do such kind of code, it will rotate our mind, not the box. So to explain simply, what's happening here is, so we are going through each column and each row, but in the reverse order. And if we find a star, then we are taking the starting position at row minus 1th position, which will be, since the row is from last, the row decreases, so we are taking the next row. So leaving the stars row, we are taking the next row, which is the top row. Okay. And if we find a hash, I mean stone, we are changing uh, that row to dot empty space and changing starting position to hash. But if the start position and the hash are, I mean row and start are same, then it will take, I mean it will remove hash and it will add hash. That's it. uh, and if it has a dot instead of star, I mean instead of, and if start is not the position as rows, then row is obviously greater than start, because uh, start is always one value lower than row, and row increases uh, along the way. So start always will be at the bottom and row always will be at the top, since we are coming from bottom to top. So if we find a uh, empty space in the bottom, then we are moving that we are moving the stone we currently have at the current index to the starting position. If the starting position has a stone instead, then swapping two stones won't be a problem. And if the starting position has a empty position, then it's a valid swap. And if the start has I mean, if we find a star instead, then we are taking the next start, right? So that's it, guys. I hope you guys understand and enjoyed the thing. uh, let's meet again with the next problem, and until then, goodbye and keep pushing hard and work hard. Bye, guys. Thank you.